Hey guys, welcome to Straight Math, and what we want to do here in this tutorial video is, once again, we're going to go ahead and take a look at factoring a quadratic, but now we're going to kind of step up our game a little bit. We want to take a look at a quadratic where the leading coefficient is something other than 1. Let's go ahead and give this one a try. What if I asked you to do 4x squared minus 12x plus 9 is equal to 0. Well, once again, you should quickly recognize this as a quadratic because of the x squared term, and you know that it fits this general form: ax squared plus bx plus c is equal to 0. But the issue with this one, or what's going to cause us a little bit more trouble, is that in this case, that leading coefficient, a, is not a 1. My leading coefficient is now a 4. This makes this problem, factoring this, a little trickier. Now, you may have learned a couple of different methods. I'm sure you probably have seen all of them. There's one where you can draw yourself a little box, you put 4 little squares in it, and you can find your factors that way. There's one where you make an x, and as you fill in the x, you find your factors that way. I prefer the table just because I think it's a nicer way of showing all of the information, right? Because this requires a little bit of guess and check. And if I'm going to have to guess and check, or at least make an intelligent decision, I want to be able to see all my options. And as far as I know, the table method is really the only one that allows you to list all of them out and sort of systematically go through the one that you want to use. Well, all of them require you to systematically go through your options, but at least the table method, you get to see all of your options as you go through them. So I'm going to do that. I'll show you the table method here as we do this. But here's my problem. What I need to do is I need to find two numbers. And I'm going to use the table to do it. And I'm going to use those two numbers to replace this guy right here, this b. So here we go. Let's set up our table, and I'll show you what the table is going to look like and then how we're going to use it. All right, now here's the way the table works. Remember, we're looking for two numbers. And here's what I need. I need those two numbers, whatever they are, I need those two numbers to multiply to a times c. A times c. Well, for me, in this example problem, a times c is going to be 4 times 9, which is 36. So I need two numbers that multiply to 36. Well, there's a lot of options. Let's go ahead and get them. I could do 1 times 36. I could do a negative 1 times a negative 36. Let's see, I could do the 9 times 4. Could do 9 times 4. I could do a negative 9 times a negative 4. Boy, there's a few others. I could do 12 times 3. I could do a negative 12 times a negative 3. We got a lot of options here. Let me slide this up a little bit so we can see my table, because I got a couple more to go here. So I've got my 12 and my 3. I got my negative 12 and my negative 3. I think this will be my last one. I'm pretty sure this is the last possibility for factors. I could do 6 times 6, or a negative 6 times a negative 6. Now again, the reason that I like this table method better than the other ones is because what it does, it allows me to list out all of my options. Now, of course, as you get more practice with these and you get better at them, you probably won't have to list all of them out. You may be able to just think through them in your head and find the one that works best for you, which would be awesome mental math. That's good mental math. But for now, since we're doing it together here, I've listed out all my factors. So now what I do is, how do I know which one's the one I want, right? I know I'm looking for two numbers. I need those two numbers to multiply to 36, but I got a ton of options here. How do I know which one's the right one? Well, in addition to my two numbers needing to multiply to a times c, I need those two numbers to sum to b. Well, for me, b is a minus 12. And as I go ahead and take a look at this list, it turns out only one of these potentials also sums to a minus 12. And it's this one, negative 6 plus a negative 6. Again, feel free to pause the videos, run through, check them all. You'll find that this is the only one that sums to a minus 12. So I found my two numbers. Great. What do we do with it? Well, here's what we're going to do with it. Rewrite my problem. I had given you 4x squared minus 12x plus 9 is equal to 0. But I just found two numbers, negative 6 and negative 6. And I'm going to replace my b with those two numbers. So I'll have 4x squared minus 6x minus 6x plus 9 is equal to 0. Now, why? Why replace b with the two numbers I just found in my table? Well, here's the reason why. What I've now got in these four terms is a GCF. What I'm going to do is go ahead, split these guys up, right, using parentheses, and pull GCFs out of each of those quantities, right? So here we go. I'm going to do the first two. I'll do the last two. And let's go ahead and find GCFs. Well, 4x squared minus 6x. Well, what I can pull out of both of those guys would be a 2 and an x. So let's go ahead and pull that out. I pull out a 2x. Pull out a 2x. There we go. And what that's going to leave me with is a 2x minus 3. What about the next one? Well, I have a negative 6x and a plus 9. Well, what I can pull out of both of those actually is a minus 3. If I pull a negative 3 out of both of those, I pull a negative 3 out of a negative 6, that leaves me with a positive 2x. And if I pull a negative 3 out of a positive 9, leaves me with a minus 3. How do you know you did it right? Well, here's what you're looking for. You're looking for the quantities inside of the parentheses to be the same. 2x minus 3, 2x minus 3. I know I did it right. Now all I have to do is write my factors. And here's how you get your factors. You're going to take the GCFs, 2x and minus 3. You're going to write them together as one of your factors. Your other factor is going to be the quantities left inside of the parentheses, right? So the 2x minus 3. Now, if you were asked to factor this quadratic, you just found your two factors. If you were asked to solve the quadratic, all you have to do is use the zero product property to split them up and solve each one for 0, in which case you would find that x is equal to 3/2. Why do I only get one solution? Well, the reason I only get one solution is because this quadratic, actually the vertice of the quadratic rests on the x-axis, so I only have one point of intersection for this quadratic with the x-axis, and it happens to be at 3/2 or 1.5. In fact, let me draw you a quick little sketch. What you would find if you were to go ahead and graph this quadratic is that at 1.5, right here, right at 1.5, that's where my parabola would touch the x-axis. And so if you were to graph it, you'd have a parabola opening up, and it touches the x-axis at a positive 1.5 or 3/2. Guys, thanks so much for joining me in this tutorial video on how to factor a quadratic where the leading coefficient is something other than 1. I'll see you guys next time on Straight Math.